So, good morning, class. My name is Collins, and I'm going to take you through physics. And today, we are going to study about electricity and magnetism. Okay, so I hope you can all see my document. That is the PowerPoint presentation for this unit, and the objectives of this class is to, by the end of the lesson, we would all be able to describe the effect of magnetic fields on moving charges. Use the right-hand rule 1 to determine the velocity over charge, the direction of the magnetic field, and the direction of the magnetic force on a moving charge, and also to calculate the magnetic force on a moving charge. So we can now continue. So in the introduction to forces on moving charges in magnetic fields, we know that electricity and magnetism, they are related phenomena, which are phenomena produced by the electromagnetic force. Together they form electromagnetism. A moving electric charge generates a magnetic field, and we also know that a magnetic field induces electric charges movement, producing an electric current. The magnetic field exerts force on moving charges, and so they exert forces on other moving of all which have moving charges. So I would like us to see on how we can calculate the force. So we want to calculate the force on the rod due to the earth magnetic field. If you throw it with a horizontal velocity of 10 meters per second due west in a place where the earth magnetic field is due north parallel to the ground. So when you use your hand, you just use this hand of yours, the right hand. You find that we have the force, we have the magnetic field that is due north, and we have also the thumb that is showing the velocity. So for a positively charged object moving due west in a region where the earth magnetic field is due north experiences a force that is straight down as shown. A negative charge moving in the same direction would feel a force straight up. So on the formula, I can see some charts. Okay, Avikoke, can you hear me now? Hello? Can you respond please if you can hear me? So let us continue. I hope Avikoke, can you hear me now? Avikoke, can you hear me? So let's continue. The magnetic force is, the formula is given by F is equals to Q multiplied by V, which is velocity, Q is the charge, and B, as we had said earlier in our first we had said that B is the Earth's magnetic field. So we see that using the sin theta is equals to 1, since the angle between the velocity and the direction of the field is 90 degrees when using your thumb and the fingers. See the 90 degrees. So entering the other quantities of the yields. So in summary, the magnetic field exerts a force on a moving charge Q, the magnitude of which is F is equals to Q multiplied by V multiplied by B sine theta, where theta is the angle between the direction of V and B, and the SI unit of the magnetic field strength B is said to be Tesla and is related to other units. We can also say that the direction of the force on a moving charge is given by the right-hand rule, which can be stated as: point the thumb of the right hand in the direction of B, the fingers in the direction of B, and are perpendicular to the palm point in the direction of F. We can say that the force is perpendicular to the plane formed by V and B, since the force is zero if V is parallel to B. Charged particles often follow magnetic field lines rather than cross them. So I hope you have now understood from the objectives. We can say that you have understood about the effects of magnetic field using the right hand rule, and I will send you an assignment to calculate the magnetic force on a moving charge. So until next time, have a good day. You can now dismiss.